Hello friends, in this video I am going to explain the insertion in the binary search tree in the way of an iterative function. That is, we are going to use the iterative approach in the operation of insertion in a binary search tree. We have discussed in one of our previous videos the insertion in a binary search tree in a recursive manner. So in this video I am going to show you how to insert a new node into the binary search tree, into an existing binary search tree in an iterative way, that is taking the loop construct into our mind and writing the code in that way. So we are going to write the code and explain you what I have done with the code with a pictorial example alongside. So let me just recapitulate what is the insertion process of the binary search tree first. That is, if we have a binary search tree like this, suppose this is a binary search tree 10, 5, 18, something like that. If a new node, if you want to insert a new node like say about 12, we want to insert this 12 into this binary search tree, what will be our operation, the procedure to be followed? That is, 12 will be compared to 10. 10 is less than 12, that is 12, that the new node value is greater than the root node value. Then we will go to the right subtree and then again compare this 12 with this new root node value, that is 18, and see that 12 is less than the root node value 18, and we go to the left subtree and see that the left subtree is nothing but a null. That is, the left pointer of this node containing 18 points to null, and then in that case we will just directly insert this 12 over here. So this is the insertion procedure which is to be followed in the binary search tree. So that can be done in a recursive manner, as has been discussed in a previous video, and in this video I am just going to do this in an iterative manner and come back to you after writing the code. So I have written the code and let me explain you what I have done. Again, we are going to just write the binary search tree node, the structure definition of binary search tree node, that is type def struct bs node in data bs node struct bs node star left star right, then bs node. So this is the structure definition of a node, of a typical node of a binary search tree. So I have taken two pointers of this to this data structure's bs node, that is the bs node star root, bs node star new node, and a function is not going to return any value. That's why the return type is taken to be void, and the name of the function is taken by me as itins, that is denoting that it is an iterative insertion procedure. So you can give any name of your choice, and after that we have written the code in this manner. We have used the iterative approach over here, that is, we have used the while loop in writing this code. And let me show you, just let me explain you the code in a way as to compare it with a sample binary search tree, with a small binary search tree I will draw over here, and let you understand what I have done over in this code. So let me just draw a binary search tree like this. Suppose this is 10, this is 15 or something like that, or this is 5, this is 655, this is 855, this is 755. And the newly inserted node, suppose 12 is to be inserted, which is in the memory location 955. So suppose this is the entire scheme of things in our example, that is, this is the binary search tree, and this is the new node which is to be inserted into the binary search tree in an iterative way. So I have written like this: while root not equal to null. This is the first condition to be seen or checked in order to just enter the entire loop construct of the iterative approach. That is, while root not equal to null. See this, this root is not equal to null. Suppose this 655 is not null, so root is not equal to null. So in this way we enter this while construct. So after that we have written if new node less than, if new node data less than root data. So new node data is nothing but new node data is 12. It is it less than the root data? No, it is not less than the root data. So we skip this entire if block and come to this else block and see what I have written over there. If root right equals null, if root right equals null, see this, is root right equals null? No, 655 has a right pointer pointing to 755 memory location, so it is not null. So we will again skip this if portion and come to this else portion and see what I have written over here. Root is equal to root right. So root will be reset to what? Root right. So root will be reset to root right. So now the root will, previously the root was 655, now the root will become how much? 755. Root will contain a value 755, that is the address 755. Now again we come to this, this is the while loop and this is the end of the function. Suppose again we enter the while loop. Again we enter the while loop and the while loop says that while root not equal to null, then we will again try to enter the while loop. Let me check the condition first. Root not equal to null. Is the root not equal to null? Yes, it is not equal to null. It is 755. So we will enter the while loop for the second time and see whether this if construct holds good now. If new node data is less than root data. New node data is 12 and root data is now 15. So it is definitely 12 is definitely less than 15 and we are going to execute this if block and never go to this else block. Now see what I have written over here. If root left equals null, if root left equals null, see this, root left is equal to null here because 755, the address location 755 containing the value 15 has a left pointer and a right pointer, both of them points to null. So the left pointer is null. So in that case what we will do, root left is equal to new node, that is directly we will insert this 955 location to be joined with the left pointer of the 755 memory location. So by this code we will just join the left pointer to this 955 memory location. So this is what we are going to do. This 12 will be joined as the left pointer to this location 755, that is 955 will be now over here. So this 955 is inserted over here and then as we have inserted the new node, we will just write this piece of code, this expression statement, root is equal to null in order to get away from the entire iterative procedure. So root is equal to null, we set the root to null now, so that we can come out of the entire process. So root is equal to null means now root is equal to null and we will try to enter this while loop and see that while root not equal to null is the condition to enter the while loop and root is equal to null means we are not going to enter the while loop and go out of this entire while loop construct over here and come to the end of the function body. So in this way we have taken the approach of the insertion in a binary search tree in an iterative manner. So if you have any doubts or queries pertaining to this entire explanation along with this example, you can well post your doubts and queries into the comment section below so that I can address them. Thanks for watching this video.